Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 3-6 for algebra, equations and problem solving. Our objectives are to define a variable in terms of another variable and model distance, rate, and time problems. Okay, so we have a couple of definitions because these are the type of problems that we're going to be concentrating on to a big part. Consecutive integers are simply integers that differ by 1. Okay, so an example of 50 and 51 are consecutive integers. -3 and -2 are consecutive integers, and so on. Okay. An object in uniform motion is one that moves at a constant rate of speed. Often, distance equals rate times time is applied to constant motion problems because we either assume or know that some things are in constant motion, in a uniform motion. Okay, let's go ahead and look at our first question. Consecutive integer problem. The sum of 3 consecutive integers is 72. Find the integers. Okay, so basically what this is asking us to do is take the first integer plus the second integer plus the third integer and make that equal to 72. Okay, you want to define your integers, so x is the first integer, x plus 1 is the second integer, and x plus 2, or x plus 1 is the third integer. So we have x plus 1 plus x plus 2 equals 72. Just fill that in here because this is where we're going to be working. When I combine like terms, then I have 1, 2, 3 x's, so I get 3x plus 1 plus 2 is 3. So 3x plus 3 equals 72. I'll subtract 3 from each side. So 3x equals 69. And then I'll divide each side by 3. So x is 23. So if x is 23, x plus 1 is 24, and x plus 2 is 25. The three integers are 23, 24. Ooh, I'm sorry. You can't see that. There you go. The integers are 23, 24, and 25. Okay. All right, so that is an example of a consecutive integer problem. Okay, I'm going to move on to example number 2. At this point, you didn't have a quick check right in there, so just move on with me. An airplane left an airport flying at 180 miles per hour. A jet that flies at 330 miles per hour left 1 hour later. The jet follows the same route as the airplane on parallel altitudes. How many hours will it take the jet to catch up with the airplane? Okay, so basically we have two different things here. We have a plane, an airplane, and then a jet. So I'm going to define time, t, as the time that the airplane travels. And t minus 1 is the time that the jet travels. Now, you might find it helpful to use a table like this. If you don't, it's fine. I'm just going to walk through it. You're going to have your own way of organizing information and presenting it, but this is one way. So for the airplane, the rate is 180 miles per hour. So its distance, rate times time, is going to be 180 t. For the jet, its rate is 330 miles per hour, its time is going to be t minus 1 because the jet left an hour later. So its distance is 330 times the quantity t minus 1. Okay, again, notice I'm using the same variable for each of these, relating one back to the other. Okay, so since they're going to, you want to see when they catch up, the jet catches the airplane, they'll have traveled the same distance at that point, or equal distances. So I set their two distances equal to each other. Go ahead then, and you have 180t equals 330 times the quantity t minus 1. I'll distribute. So that gives me 330t minus 330. Okay. At this point, I am going to subtract 330t from each side. And then I get negative 150t, whoops, my t is already there, sorry, is equal to negative 330. Divide each side by negative 150. And I end up with t equal to 2 1/5. So t minus 1 is going to actually be 1 1/5. So the jet will catch up with the airplane in 1 1/5 hours, because that's how long it's going to have to fly in order to catch the airplane. So the airplane's going to have to fly 2 1/5 hours to travel the same distance that the jet will travel in 1 1/5 hours. So the jet will catch up in 1 1/5 hours. Remember, this is just simply negative 330 divided by negative 150, transformed into a mixed number. Well, actually 2 in this case, this one, and then you subtract, so there you go. Okay, at this point you have a couple of quick check questions. Pause now if you'd like, or continue on and do the rest of the examples with me and then come back. Number 3 is an opposite direction travel. Two jets leave Dallas at the same time and fly in opposite directions. One is flying west at 50 miles per hour faster than the other. After 2 hours, they are 2,500 miles apart. Find the speed of each jet. Okay, so what we'll do is, let's do this. Let x equal the speed of the jet flying east. Okay, then x plus 50 is going to be the speed of the jet flying west, because it's flying 50 miles faster than the other. This is why it's very important to define your variables, because the equation you write is going to depend upon how you set up your variables. So if you're doing this from scratch without any guidelines like are presented here in the notes, your equation might look a little bit different. So again, you always want to define your variables so that when someone else is looking at this, and even when you're working this, you know what you're doing. Okay, so the eastbound jet has a rate of x, and it's they're going to fly for 2 hours, so the time is 2. Eastbound jet's distance traveled is 2r, rate times time, 2r. Westbound jet is going to travel at the speed of x plus 50. So I'm going to multiply that by the time of 2 hours, 2x plus 50. This time, when they're 2,500 miles apart, you would add these, because the distance of the first jet, the eastbound jet, plus the distance of the westbound jet should total 2,500. So this is why we add them in this problem, and we didn't in the other problem. Okay, so when I distribute, I'm going to get 2x plus 100 equals 2,500. So 4x plus 100 equals 2,500. I'm going to combine like terms. Well, I did that, sorry. Now I'm going to subtract 100 from each side and simplify. So 4x is 2,400. I'm going to divide each side by 4. So 2,400 divided by 4 is 600. So x is 600. The speed of the jet flying east is 600 miles per hour. Oh, they have my label, sorry. And the jet flying west is flying at 600 plus 50, or 650 miles per hour. And there you have that. Okay, there is more, so you do want to turn the page. You have your quick checks 2 and 3 on the back of that page. Please have all of these quick checks completed before you come to class. Bring those and any other questions that you might come up with as you're working through these. Remember, as always, you can always go back and read through your textbook as well for similar explanations of the same concepts, but they do have different examples, and you